So in example 1, we looked at 4 different graphs and we identified the x and y intercepts of each graph, okay? So now what we're moving toward is how to determine intercepts algebraically from the equation. Remember, when we looked at the graphs in example 1, there was no equation associated with the graph. We wrote down the intercepts solely based off of the graph. Okay, so what we're going to do now is we're moving toward examples where you're given the formula or the equation. Okay, you're not given the graph. You could graph the equation out, but what we're going to try to do is learn how to find the intercepts without relying on the graph or the picture. Okay, so what we're going to do before we do example 2 is we're going to try to come up with a method for determining intercepts algebraically. Okay, so at the bottom of page 2, there's some questions we need to answer. Okay, so the first one says, looking back at example 1, what do all of the x-intercepts have in common? Okay, so let's go back to the first page. Okay, so let's look at all the different examples. Okay, all right, so here we go. In example 1a, we look at our x-intercepts. They were negative 3, 0 and positive 3, 0. In example 1b, there were no x-intercepts. If you look at page 2 in example 1c, again, the x-intercepts are negative 2, 0 and 2, 0. And then we're not going to worry about example D because that was the crazy example that had tons of x-intercepts. So what you should notice, what all these x-intercepts have in common is this. Okay, the y-coordinate is always 0. Okay, if I flip back to example 1a, the same was true here. Okay, your y-coordinate is always 0. Okay, so let's go ahead and jot that observation down. Okay, so what all the x-intercepts have in common is that their y-coordinate is 0. Okay, so every time you have an x-intercept, the y-coordinate is 0. Okay, and that makes sense because if you're an x-intercept, you lie on the x-axis, which means your y value has to be 0. Okay, the second question we need to answer, what do all the y-intercepts have in common? Okay, so if we go back through the examples in example 1, okay, example 1a did not have any y-intercepts. In 1b, the y-intercept, if you look at it, it's 0, negative 1. Okay, going back to page 2 and looking at example 1c, okay, the y-intercepts are 0, negative 2 and 0, positive 2. Okay, you still see a 0. Okay, but now it's the x-coordinate. Okay, so every time there is a y-intercept, the x-coordinate is 0. Okay, so that's what's going on here. Okay, so that's what you should be observing here. Okay, so let's go ahead and jot that down. Okay, so all the y-intercepts have an x-coordinate of 0. Okay, so we're going to write their x-coordinate is 0. Okay, so these two observations, okay, the fact that every x-intercept has a y-coordinate of 0 and that every y-intercept has an x-coordinate of 0, this is going to help us come up with an algebraic method for determining intercepts from the equation. Okay, so at the top of the page 3, here is the procedure for finding intercepts algebraically. If you want to find an x-intercept, you're going to set the y value equal to 0 in the equation, and you're going to solve it for x. Okay, and again, that is because every x-intercept has a y-coordinate of 0. Okay, to find the y-intercepts algebraically, you're going to take your equation and you're going to set x equal to 0, and then you're going to solve for y. Okay, and again, this is going to work because we've seen from the graphical method that if you are dealing with a y-intercept, its x-coordinate is 0. Okay, so this is a very important box. Okay, this is going to give you the procedure for finding x and y intercepts algebraically.